Okay, we'll see the class today, chemical bonding. Ah, let me see today what is chemical bonding. Now, anybody, what is the definition of bonding, chemical bonding? Is it possible for you? Chemical bonding definition. Screen is visible to everyone, no?
Yes, sir.
Yes, sir,
Yes,
it
right.
is.
Yes. Now let me see the what is the chemical bonding,
Yes, sir.
how actually represented, and is what is the objective of this chapter. Everything we see now. If you observe this one, this is a shake handing, right? Strong shake hand, which indicates what happens strong. When you have a shake hand, that is what very strong. That means both are actually what? A very good friends, isn't it? If they are very good friends, what happen? They're having high, strong bonding actually. Now let me see now here Na plus and Cl minus. Na plus and Cl minus both are getting what? A bonding, and you got a this type of compound actually. Or this type of compound, isn't it? Because of bonding actually. A compound is formed like this. We are calling that one as a sodium chloride actually. Now how it is formed, let me see now here. Now the strong bond when you get, generally what happen if you imagine, because already in the structure of atom you know this one, this is a p orbital, this is also what? P orbital, dumbbell shape they're having. The shape of the p orbital is dumbbell shape, right? So now they're overlapping. How it is? The both orbitals are overlapping here, and this orbital is providing one electron here, and this p orbital also providing one electron. Now they are both are forming a covalent bond. This is because of strong sigma overlapping. Now both are getting what here? Sigma overlapping. So because of sigma overlapping or because of ionic bond, what happened? You are getting a strong bond actually, right? By how you are getting the bond actually? This because of what? Overlapping. So when the orbitals are overlaps like this, they are going to get a strong. Now, if you observe this one, what happened? This is sideways overlapping. You observe what happened? Both are sideways overlap here. These two are sideways overlap here. Now here, the bond is weak, and you are going to get here pi bond actually. Okay, the pi bond is weak when you compare with sigma bond. So sigma bond, what happened? Overlaps, what happened? Axial overlapping. On axis, overlapping takes place. But in the pi orbital, isn't it? The bonding takes place sideways actually, isn't it? So all these we discuss in what? In the next topic actually. Now, if you observe what happened, matter generally made upon by either elements or substances like this here. Many substances. For example, hydrogen, nitrogen, or carbon dioxide, water. Like that, what happened? Matter is what? Made up. So substances consisting of same atoms. For example, hydrogen. Hydrogen is called element. Atom is what? Single one. But what element means, what happens? Same type of this type of atoms are consisting. Then they are called what actually element, isn't it? Next, the simplest particle or smallest particle of the matter, which may not independent exist but takes part in the chemical reaction. We're taking what? Chemical reactions here, isn't it? So that is called what? Atom. This is the smallest particle of the matter, isn't it? Which may be independent, may not be independent existence, but take parts in what? Chemical reactions. That is called what actually? What? Atom. In examination, nobody asks what is the definition of atom. Remember, just only what introduction terms. Atomic structure, when you observe here, what happened? The basic unit of matter. The basic unit of matter, if you observe what happened, that consists what happened? nuclei, and also what electrons. Nuclei and electrons. These are the basic units of atom. Now, for example, if you observe any atom, does it exist independently? No, except noble gases. For example, if you observe what happened, noble gases, they exist independently. Like what happened, helium independently exists. It never formed with any type of compounds. Neon independently exists here. Argon, krypton, little bit xenon, isn't it? These elements independently they exist in the nature. But all the elements do like that? No. For example, if you observe what happened, chlorine. Okay, chlorine existing independently is what very difficult. Okay, it exists as diatomic like Cl2 or NaCl or KCl in the form of compound nature or in the form of molecular nature. Hydrogen, if you observe in the form of molecular, you can't observe atomic hydrogen in the nature. Atomic hydrogen is not possible. Within the reaction, it's possible. In situ, within the reaction, it is possible, but exists in the form of what? Molecular structure. Otherwise, what happened in the compound structure? If you observe what happened, and this is the actually what animation of what an atom, where actually the blue color is revolving around the nucleus, and that the center is nothing but called nucleus, which is having positive charge. This is about the atom. Actually. Now, what is a molecule? Now? The meaning of molecule. Now, the smallest particle of the matter, isn't it? Here, the smallest particle of the matter, okay, with independent existence is called what molecule. Now, in this case, a group of atoms exist. One species having same properties is known as molecule. This is very important thing. Having same properties. For example, if you observe what happened, hydrogen. Now here, this molecule is made upon by same atoms. So you may get what? A molecules with different atoms also, like carbon dioxide. Molecule is made upon by carbon dioxide. That means carbon plus oxygen. Now, the properties of carbon and the properties of oxygen is quite different with what? Carbon dioxide. Isn't it? The property is completely different when you compare it with carbon and oxygen. Once they form molecule, what happens? They lose their identity. Which one? Carbon and oxygen, they lose their identity and they form what? A different property called carbon dioxide like this. Water is one of the molecule, isn't it? This is called ethane. C2H6 is called what? Ethane. These are nothing but what? Molecules actually. All these are what? Molecules. What is chemical bond? This is very, very important because our chapter name is called what? Chemical bonding and molecular structure. So that is the reason what happened. The chemical bond definition is very, very important. So what is that bond actually? So first of all, we see the force of attraction, which holds, which binds various constituents like what? Atoms, molecules, ions together in different chemical species is called what? Chemical bonding, isn't it? So just simple thing, binding, isn't it? Holding or binding together. These are the key points for us. For example, we'll take an example. Now you observe here, these are the atoms actually. Now there is a force which is operating between hydrogen and oxygen, holding these two atoms with a chemical bond like this. Or here also same thing like this. Water, ethane, isn't it? There are nothing but what? Molecules which have completed something what? Their bond action. What is the reason why an atom combines to form a molecule? You may get doubt actually. Hydrogen, why converting into H2? What is the reason behind this? Isn't it? So very simple, to get the attained stability. To get the stability. Every atom want to get the stability. Isn't it? So how we actually want a job for getting a stability. Isn't it? We want some money for getting the stability. Isn't it? Similarly, what happened? Every atom want to attain stability. How they attain stability? By losing electrons or by gaining of electrons. So hydrogen with one electron is a single electron configuration. Want to get doublet configuration by converting into hydrogen. Now we get a doublet configuration, which is stable configuration, helium configuration, stable configuration, inert gas configuration, which are stable one. Therefore, what happened? To get the stability, they undergo what? Chemical reaction. They combine to form what? Molecules. Isn't it? So if they ask what happened, why do atoms combine to form a molecule? What you have to give? To attain the stability. Isn't it? So now how to attain the stability? Now, for example, hydrogen, when you observe, hydrogen is atomic hydrogen is highly energetic. It is, isn't it? So by decreasing their energy, okay, by releasing their energy, they attain the stability, isn't it? If you have highest energy, what happens? They're unstable. So they lose energy and they attain the stability actually. So what first thing is what? By decreasing the energy and attaining the octet configuration. So that what happens? They get the octet, 8 electrons in their outermost shell. So getting 8 electrons in the outermost shell is called what? Octet configuration. Isn't it? Octet means what? 8 electrons in outermost shell is called what? Octet configuration. Now, do all elements undergo molecular formation or chemical combination? No. Except noble gas, almost all will undergo what happened? Chemical combinations. Why noble gases do not take place? Anybody? Why do not noble gases do not undergo chemical combination?
Because they are already unstable.
The second reason is already what happened. The second reason already what happened here. Satisfied. Octet configuration is already there. So why they undergo chemical reaction? Isn't it? So here noble gases already they are having octet configuration. Therefore, they do not undergo any type of chemical combination. Isn't it? All these elements, helium, neon, argon, krypton, xenon, radon, isn't it? All these do not undergo any type of chemical combination, isn't it? With any other elements, not only with themselves or with any other elements, isn't it? Because they're having a stable octet configuration, isn't it? So they may ask this type of questions here. Why noble gases do not undergo chemical combination? You may give like this, because they are already attained what? Octet configuration, right? Next, why an atom combines to form molecule? Experimentally, when you observe here, what happened? The attractive forces, whenever the attractive forces, the new attractive forces, which are more than what? Repulsive forces, isn't it? Repulsive forces and attractive forces, if you observe what happened, when attractive forces are dominating, then the chemical bond is forming. So whenever the attractive forces were dominating, what happened? Which one? Repulsive forces. Then only we get the chemical bond. Now, when you get attractive forces between electron and the neutron, isn't it? With positive and positive, we get attractive forces. This is called attractive forces. That means with the nucleus and electrons, you're going to have what? Attractive force. Now, when you get repulsive forces with the nucleus and nucleus, the electron and the electron, isn't it? With the electron, what happened? You're going to get the repulsive forces. So when you overcome these repulsive forces, what happened? You're going to get a chemical bond action. Now, whenever what happened? Two atoms approach each other. Whenever two atoms are approaching each other, their potential energy decreases. Their energy, what happened? Will decreases and they get the stability, isn't it? Now, I will show that one very beautiful diagram in the next slides. Now, whenever the net force of attraction is balancing what happened, net force of repulsion, and the system acquires what? A minimum energy. So whatever the excess of energy will be what? Gets what happened? Less, decreases here and get the minimum energy. At this energy, what happened? Both what actually what happened? Balance. That means the attraction forces and repulsion forces will get a balance actually. Now, for example, if I see what happened when a bond is formed, between two hydrogen atoms, the hydrogen molecule is more stable than that of isolated hydrogen atoms. For example, this is the hydrogen. Okay. Now, what I'm doing here, hydrogen and hydrogen, both are combining. Both two hydrogens are combining. Now we are going to get a chemical bond. Got a chemical bond. Right? Now, in this case, what happened? This much amount of heat will be released. How much amount? How much excess amount of energy you're having between these two hydrogens? 43,508 joules. Isn't it? 43,000, otherwise 43 kilojoules. Roughly, I'm writing 43 kilojoules. Instead of speaking like this, simply I call 43 kilojoules of heat will be liberated, whatever the excess, this is excess energy they're having. This is excess, more energy they're having in hydrogen. That is the reason what happened, hydrogen is what? Highly unstable. So once they combine, what happened? This amount of energy, what happened? Released. Therefore, they are getting the stability. Okay. So here, the hydrogen molecule is what? More stable. Why it is more stable? It got octet configuration. Sorry, it got duplet configuration. Correct? It got duplet configuration. Second thing, this much amount of energy it lost. Isn't it? When they lose energy, what happened? They get stability. Having excess energy, what happened? They are unstable. Understood here? In this way, we are going to. Now we'll see the diagram here. Now here I have taken the nuclear distance. That means what? Whatever the distance present between the nucleus and outermost electron. Now here to here, what happened? The nucleus distance, what happened? Increasing. The distance between the nucleus and outermost shell, what happened? Increasing, right? Next, this is the potential energy. Whatever that electrons, if you observe what happened. Okay. Now I have taken the hydrogen. Okay. Both hydrogens I have taken. So the energy of the hydrogen is here like this. Here, the hydrogen atoms energy, atomic hydrogen energy is something here like this. Okay, right. Next, you take here. Okay, here you take. What happened? They're combining now. Okay, they're combining now here. Now what is happened here at this point, if you observe what happened, they got overlapped. Both hydrogen atoms are overlapped. Here both electrons will be represented like this. They're overlapped like this, isn't it? Now, if you observe what happened, what is the distance here? The distance, internuclear distance, if you observe here, what happened? 74 picometer. Energies you are getting here. This is the energy. At this energy you are having how much here? 436 kilojoules of energy. Minus indicates what happened? Released. Right? Now, in this case, what happened? You observe here what happened. When they are independently, what happened? Their energy is what happened? Very high. Very high. Isn't it? Their potential energy is what? Very high. And internuclear distance, if you observe what happened, from the nucleus to electron, what happened? The distance also what? Away. So once they form electron, they come near, no? You observe what happened? They are away from each other. Isn't it? Internuclear distance from here to here. It's the distance, internuclear distance. Internuclear distance. Now here, once they overlap, what happened? The internuclear distance is decreased. And they have released some energy, something what? Minus 430, that means 436 kilojoules. From here to here, what happened? The energy dropped here. How much dropped here? 436 kilojoules of energy is released here. Isn't it? So in this way, we can represent in the diagrammatic format. Can you say the answer for this one? Matter is made up of dash type of elements.
So both
Sir,
A
both A
and
and B.
It is maybe same. Also, like hydrogen or carbon dioxide, you observe what happened. What is the atom?
Sir, basic unit of
Sir, basic unit of matter.
Basic unit of matter. How an atom combines to form molecule? Which answer will be? This is very important.
By decreasing.
by decreasing energy.
decreasing energy.
In any case, always what happened? Decreasing of energy only. Just now I shown you, isn't it? In the graph, the hydrogen molecule energy decreased to what? How much energy is decreased here? Around 43 kilos
436.
liberated here. So answer always, this is important beta. By decreasing of energy, what happened? Molecule will be formed actually. The following does not form molecule beta.
Noble gas.
Noble gas.
Noble gas.
Does not form actually, right?
Noble gas.
Now let me see some more points. Why noble gas are inert in nature? When you observe helium, it is having duplet configuration. Okay. Now here if you observe what happened, all are having outermost shell. If you observe what happened, in any case, you consider the helium, neon, argon, krypton, xenon, radon, isn't it? All are having what? Which type of configuration? Outermost shell, if you observe, octet configuration. When you get outermost shell is what? Octet configuration. That will be more stable, except what? Helium. Helium with a duplet configuration also what happened? Stable. Why? Because in this only one orbit is there. In this only one orbit is there. In one orbit, Okay, we can place maximum how many electrons? Only 2 electrons. That is the reason we can consider for helium, duplet is what? More stable configuration. Remaining octet configuration, isn't it? Having the outermost shell, if they're having 2 electrons, 8 electrons, what happened? They're highly stable. Now you may get a doubt actually. What doubt you may get here? If you observe what happened, magnesium, barium, magnesium. Okay. Now configuration of barium will be better. Anybody? Magnesium. What's the configuration of beryllium and magnesium beta?
CH2.
हाँ तो यार ये जो मैंने लिखा आपको दिखाई नहीं दे रहे? Is it visible for you? Beryllium, magnesium.
Yes, sir.
Now which configuration they are having beta यहाँ पर? Which configuration they are having? Duplet or octet configuration?
Duplet.
So being duplet should be stable, no? Correct or not? Being duplet, they should be stable, but they're highly unstable. They're highly unstable. Magnesium will convert easily into magnesium halides. Now here also duplet configuration is there, but when you write duplet configuration here, isn't it? In that cell, we can accommodate only 2 electrons, but in the 2s, you have 2p0 is there, no? Now 2p is empty here. If 3p0 empty, you know, 3p0, 3d0 also empty, no? So what we do in this case? What happened in this case? What happened? They can accommodate some more electrons, isn't it? So that is the reason what happened, isn't it? Beryllium, magnesium, they, even though they are having duplet configuration in their outermost shell, what happened? They are highly unstable. And one more thing, that is not a correct reason, but main reason is what? For this I have explained like, but main reason is what? When beryllium lose 2 electrons, what type of configuration you are going to get better? When you lose beryllium 2 electrons, you are going to get 1s2 configuration. This is helium configuration. So definitely it will attain the helium configuration. It will combine with some elements to convert into what? Helium configuration. Magnesium, it will lose, when it lose 2 electrons beta. What we get here? 2s2, 2p6 configuration. Octet configuration. Octet configuration. Right? So for getting octet configuration, when they lose these 2 electrons, what happened? They get octet configuration. So that is the reason what happened. You just remember, for helium only we get duplet configuration. Only for helium, not for all the elements. Only for the helium, isn't it? We consider the duplet configuration, isn't it? And remaining 0 group elements, you have to consider what? Octet configuration. Next, why molecules are more stable than the individual atoms? Okay. So because what happened, they want to get the less energy and they want to get the octet configuration. Same thing we have to explain here. Now this is the statement here. Atoms combine together in order to complete their octet and acquire the inert gas configuration. 8 electrons, NS2, NP6 configuration. They want to get NS2, NP6 configuration. Right? That is the reason. Now these are some questions. If you observe what happened, all these questions will be explained in this chapter. Why do certain atoms, only certain few atoms combine while some atoms do not? What is the reason? Why do atoms possess only certain combinations? Certain combination means why do that element will undergo only with that element? Isn't it? Why only these 2 elements are undergoing chemical reaction? Why this combination is not for all the elements here? Like that. And how do that molecules will get the definite shapes here? What is the shapes of the molecule? How do they get the shape here? Why water is having something what happened B shape or angular shape? Why methane is having some tetrahedral shape? This we'll discuss in this chapter actually. So how many number of theories are there that we'll discuss in the all this in this chemical? Correct answer beta is number of outermost electrons in the noble gas is
Sir, either 2 or
Either 2 or 8.
right.
Option
Either
D.
2 or 8. Already it is formed. Energy will completely what happened? Decreases. Now let me take the second PPP. This is the main, actually our top second But here only in this PPT, you have to remember that for getting octet configuration, by decreasing the energy, elements will undergo chemical combination, right? Now let me see the important thing, Lewis dot structure. Already I think 10th class you got the Lewis dot structure, but anyhow just we see this Lewis dot structure. What are the theories actually what happened? How many theories are there? Let me see discuss. So this is the Crozer-Lewis approach theory. We'll discuss today only. And valency, Vesper theory, valency shell electron pair repulsions theory. It is a very, very important theory. In coming days, we discuss this one. And VBT and MOT theory, isn't it? VBT, these are the theories we are going to discuss in this chapter. Okay? Today, we'll start this Crozer-Lewis approach. Okay, remaining 3 theories we'll discuss in the next classes. All these 4 theories are very, very important for us. When you observe how many types of chemical bonds are there, very important beta. How many types of chemical bonds are there? The first one is ionic bond. The second one is covalent bond. Third one is the metallic bond. Metallic bond generally forms between metal and metal. Covalent bond generally form between more electronegative elements. And that means more electronegative elements means what happened? That electronegativity difference is what very less. Okay, in which electronegativity difference between 2 atoms is what less. Then we get the covalent bond, in which what happened? Electronegativity difference is maximum, more. Then we get the ionic bond. For example, when you observe sodium and the chlorine, between these two electronegativity difference is very high, isn't it? This is having something around 1.1 or 1.0. Okay, this is having 1.0, and this is having 3 point something what 2 something like this. How much difference you are getting? 2.2. More than 1.9, if you get what happens, they are getting what? Ionic bond actually. Okay. Now, for example, if you take carbon and hydrogen, if you observe what happened, carbon is having something 2.1, hydrogen is having something 1.2 something. So how much difference? Only 0.9 difference. So it will be what? Covalent bond. So electronegativity difference, if they get very less than 1.9 something like this, isn't it? So or 2.1 something what? Then what happens? You will get the covalent bond. More than what happened? We get the ionic bond actually. Metallic bond purely between the metals only. So these are the some type of chemical bonds actually which are forming here, right? Next you'll see again the covalent bonds here. Covalent bonds are further classified into polar and non-polar covalent bonds here. Now polar and non-polar means what happened? For example, if I take what happened between hydrogen, a covalent bond is formed. Now you cannot write any positive and negative charge. But when you form a covalent bond between hydrogen and chlorine here, you can write a negative charge on chlorine, you can write a positive charge on the hydrogen, because they have some electronegativity difference. Whenever electronegativity difference is there, then you can get the I've written reversely. I've written reversely. This one I should write. Polar and covalent bond. Polar means what happened when you get like this hydrogen, chlorine. Here you are getting negative charge. You are getting a positive charge. Okay. So whenever if you get what some electronegativity difference, when they are having electronegativity difference and their charges are what cancelled, then we get what not cancelled. We get what happened? Polar covalent bond actually, isn't it? For example, ammonia. You take ammonia here. Hydrogen, positive charge. Nitrogen, negative charge. So because of the polarity here, because of the electronegativity here, some poles are generated like negative pole and positive poles are generated here. So you got a polar covalent bond. In non-polar, what happened? You see hydrogen, you can't develop any charges. Okay, you can't develop any charges. Nitrogen, you can't develop any charge. So they comes under non-polar covalent bond. For example, carbon dioxide, if you observe what happened, carbon dioxide, you may get what actually, isn't it? You may get actually polarities are developed here, but still it is non-polar only. Why? Because why it is again non-polar? Because they're cancelled. The charge is cancelled here because it is moving in this direction and this is moving in this direction. Both are getting cancelled. This is called what dipole moment. We discussed this dipole moment in this chapter, isn't it? The following we get that one, no problem. Okay. Let me see the first approach called Crozer-Lewis approach for explaining the chemical bonding, isn't it? Kozel and Lewis approach. Now, first of all, we should know what is kernel now. What is the meaning of the kernel? So here actually two scientists called Kozel and Lewis, they explain the chemical bond in terms of in Lewis got what happened. The Nobel Prize also for this one. Picture atom internally positively charged is called what kernel, and outer shell electrons that could accommodate maximum 8 electrons. Now, what is the meaning of this kernel? The meaning of the kernel, let me see. Now, when I write what happened, something what happened, I will take an example here. Which one I will take? What happened? Sodium I will take. Okay, best example, sodium I will take. Okay. Now, what is the configuration here? 1s2, 2s2, 2p6, 3s1. Now, when you observe, this is a sodium configuration better. Now, this is outermost shell, right? This is what? Outermost shell. This is what? Outermost shell. Now, this is what? Inner electrons. These are all actually what? Inner electrons. And that inner electrons, if you observe what happens, they're having octet configuration also. Okay, this core inner electrons, now you can call this one as a kernel. This is called kernel. Now, why you are calling specifically kernel here? Because, see, when you do any chemical reactions on sodium, I want to perform some chemical reactions on sodium. Now, this inner electrons, the kernel, 1s2, ns2, np6, will not participate in any chemical combinations. These electrons do not participate in the chemical reaction. Why? Because this is stable configuration. 1s2, 2s2, 2p6 is nothing but neon configuration. It's a neon configuration, stable octet or inert gas configuration. They do not participate in a chemical bond. Which one will participate? Which electron will participate? 3s1 electron will participate. This 3s1 electron will participate in the chemical bond. So that is the reason what happened. Whichever inner shell electrons, core electrons, which are nothing but what actually called kernel, isn't it? So in addition to this one, you can take even nucleus also. Why? Because if I write what happens, Na plus, entire thing is called kernel. Na plus is now having what? This configuration. Okay. Now you can use even nucleus also in the kernel also, because you are showing Na plus means comes under everything here. Even nucleus also will come under. Okay, because there is no reactions in this case. Understood here? What is the meaning of kernel here? According to this, atom can combine either by transfer of electrons, okay, from one atom to other atom, or by sharing of valency electrons in order to have electron configuration. So this is what octet rule is. Now, what is the meaning of octet rule? Anybody? So very simple. Atoms, they will combine by transferring of their valency electrons or by sharing of their valency electron in order to gain the octet configuration. This is called what? Octet rule. Okay, what is the meaning of octet rule? Gaining the octet configuration, 8 electrons, by losing valency electrons, or by gaining the, that means transferring of valency electrons means by gaining or losing valency electron or sharing the valency electron, we get this one. We'll take some example here. I have taken the chlorine molecule. I have taken here chlorine molecule. The configuration I am writing here, chlorine configuration will be what? Configuration here, 1s2, 2s2, 2p6, 3s2, 3p5. Including nucleus, this part comes under what actually? Kernel. Including the nucleus, it will comes under kernel here. Now this is the valency shell. This is the valency shell. Whatever the chemical combinations of chlorine because of the valency shell electrons. Because of these electrons, chlorine combining. Now how it will get the octet configuration? But anybody? 3s2 3p5, how to get octet configuration? 3s2 3p5, gain one electron. What configuration you are getting here? 3s2 3p6, argon configuration, inert gas configuration you are getting. Argon configuration, which is inert gas configuration. How? By gaining one electron. By gaining one electron. Okay. Now in this case, what it can do actually, it can gain one electron by even by sharing also it can do. No? By sharing also, you see, observe here. So this is what actually 3s2 3p5 configuration. I'm writing here 3s2 3p5. Correct? And this one also 3s2 3p5. Now this is lone pair. I am writing this one 3s2 3p5 configuration like this. 3s2 lone pair. 3p5 I am writing like this. 3p5 we are writing like this. Lone pair, lone pair, lone pair, and this one is not unpaired. Unpaired. Now which electron generally undergo in chemical combinations? Unpaired electrons, right? Now this is unpaired electron. This one. This is unpaired electron and this one also unpaired. Now they are getting what happens? Sharing now. Contributing the chlorine 1 electron here. Contributing by this chlorine also what happened? 1 electron here. So contributing equally, and also what happens? Sharing of electrons also what happened? Equally. So we got a chemical bonding. This is a by what type of thing actually? By contributing equally and sharing equally. So sharing equally, this is nothing but formation of covalent bond actually. In this way, covalent bond is formed, isn't it? You see here 287 means what happened? Like this. 2 electrons here, 2 plus 6, 8, and 5 plus 2, 7 like this. This is first shell, second shell, third shell. Okay, right. Same thing, 287, 287. Now we got 2, 8, 8, 2, 8, 8. Which configuration beta hai? Argon configuration. You got an argon configuration. So by sharing of electron, the chlorine got here what? Argon configuration. It does not convert into argon. Remember, it doesn't convert into argon because argon nucleus is different. Chlorine nucleus is different here. They're only having electrons are having same, but the nucleus is what different actually. So they do not have same type of physical properties. Physical properties depends upon the nucleus, right? I will take one more example here. Sodium I am taking here. Sodium I am taking. You have studied everything in the 10th class itself, but just we are just revising this. The configuration of sodium will be what actually? 1s2, 2s2, 2p6, 3s1. Here first shell containing 2 electrons, second shell contains 8 electrons, and the third shell contains what? 1 electron. So 2, 8, 1 actually. Now, how it gained octet configuration beta sodium? How sodium?
Sir, by losing 1 electron.
If you lose this electron, what happens? You are going to get the octet configuration, argon configuration. You are getting argon configuration here. So now NaCl definitely will lose 1 electron. Now here sharing of electron is not possible beta. For sodium do not form covalent bond. Why? If anybody asks you why sodium does not form covalent bond,
It is highly electropositive.
So not like that, you can say like that. Sodium, if it form covalent bond, what happens? It should share electron. If it share electron, it does not get the octet configuration. Okay, when sodium share electron, no, this 1 electron, they will get 1 more electron, extra 3s2 configuration it will get. So no use for that one. It only get octet configuration by what? Losing of electrons. But chlorine is different. Chlorine by sharing and by transferring electron, it will get the octet configuration. Therefore, chlorine can form covalent bond, chlorine can form ionic bond. Understood my point here? Chlorine can get octet configuration by transferring, by sharing electron, by what happened? Losing electron. That means sharing electron and transferring electrons. But in the sodium, what happened? It can get octet configuration only by what? Losing of electron. So that is the reason what happened. Sodium can form only what happened? Ionic bond, but not the covalent bond. Now let me see the chlorine now here. Let's see the chlorine configuration again. Same 1s2, 2s2, 2p6, 3s2, 3p5. Now, if you observe this one, now there is no observe here with sodium there is no chance of covalent bond. Correct or not? Chlorine with sodium there is no chance of getting what? Covalent bond. Why? Because sodium does not share any electron. Because if it share, what happened? It does not get the octet configuration. Sodium will get octet configuration with only what happened? Transfer of electron, loss of electron. That is the reason chlorine now will get the electron from here. 3s1 electron will gain by whom actually? Now we are going to get the chemical bond. 8, 7, which is 2. This one is 8. This one will be the 7 like. Now we are going to get the, now you see, observe this electron. You see, this electron is coming now. You observe here what happened? This electron is now getting on chlorine. Now this is converting into what here? Plus 1. You'll get 2 comma 8 comma 8. Now this will convert into 2 comma. Now sodium transferred its electron, isn't it? You observe here now 2 comma 8, 2 comma 8, isn't it? You got octet configuration. This is what type of configuration? Neon configuration, octet. This one is argon configuration. Now the chlorine is forming two different type of chemical bonds. One is what? Covalent bond. This one is what? Ionic bond. Right? Now sodium, because of losing of electron, what you got? Cation you got. Chlorine, because of gaining of electron, you got here anion you got. Now with positive charge and with negative charge, electrostatic force of attractions will present now. So that force of attractions coming together, isn't it? Forming which type of bond now here? Ionic bond is formed. A Coulombic force of attractions will present between the cation and anion. You got NaCl is formed, isn't it? This is the formation actually, right? So in losing electron, not only one electron, you may lose 2 electrons, 3 electrons like that. Maximum 3 electrons, isn't it? Is it possible for you? Octet rule is followed in ClO2, NOClF3, NF3. This will already be discussed in the 10th class. Anybody knows this one? Okay. If you know, no problem. If you don't know also, we will get this one in the next topic, we get this one. Okay. I will explain this one with what? A beautiful examples. Okay. No problem. This, no need for us. This is also, you know this one. Octet means having which how many electrons?
8 electrons.
Sir, 8. See,
Let me see the Lewis symbols also now. Now, in the formation of a molecule, only the outer shell, when you are writing the Lewis symbol, you have to represent only outer shell electrons only. That means only valency electrons only you have to show in the Lewis symbol. So what is the meaning of valency electrons? Outermost shell electrons. They are only showing in the Lewis symbol. When you are writing the Lewis symbol, which electrons you have to show? Valency electrons we have to show. Because they only form bond now. So that is the reason we have to show only that one. Okay, to represent the valency electrons, we have taken the Lewis symbols. The notations are Lewis symbols. Lewis dot structures also we can write here. Lewis dot structures also we can write. Now you see here, hydrogen only 1 electron. That is what? 1s1 configuration. Helium 1s2 configuration. Lithium, if you observe what happened. Lithium 1s2, 2s1 configuration. So I am showing only what happened. 2s1 configuration. This is a valency shell. For example, fluorine, if you observe fluorine, 1s2, 2s2, 2p5. So we have to show how many electrons here? Only 7 electrons. 5 plus 2. This we can't show here. So 7 electrons. 1, 2, 3, 4, 5, 6, 7 electrons. Okay, like this. For example, sulfur, if you observe sulfur configuration, 1s2, 2s2, 2p6, 3s2, 3p4. Now, this is the valency shell. Now 2 plus 4, 6 electrons we have to show here. You see, 2 here, 4, 5, 6 electrons we are showing. Now you may get doubt actually, why we are showing like this? Why can't you show something 6 electrons? You may get like this. Why can't you show something like the 6 electrons? Isn't it? Now we are shown here like this actually. And why we are shown like this? Anybody? This is wrong. This is correct. What is the reason behind this one?
because
बोलो बेटा. देखो बेटा 3s2 3p4 आपको लिखना है, isn't it? 3s2 3p4 आपको लिखना है. 3s2 हो गया 3p4. How to write 3p4? Third electron, fourth electron. Now you see this is a lone pair. This is a lone pair. So lone pairs are shown like this. These are lone pairs we are showing like lone pair. This one is the lone pair. Now these 2 electrons are not lone pair, no. They are unpaired, no. So you can't show the lone pair form. Unpaired you have to show like this. Unpaired you have to show. For example, nitrogen is there. Nitrogen. Configuration is 1s2, 2s2, 2p. So 2s2, 2p3 you have to see. Why? Because of the valency shell. So 2s2 write like this. 2p3 write like this. Half fill configuration. Now when you write nitrogen, lone pair, write down as like this. Unpaired electron. All these are what? Unpaired electrons. Write down like this. So unpaired electrons shown by single dot like this. Unpaired shown by single dot. Lone pair shown by what actually? Double dot like this. Now when you observe here, how many unpaired electrons are there on aluminum? How many unpairs are there on aluminum? Unpaired electrons are how many?
Sir,
Three,
3.
sir.
Three are. That means when you observe the Lewis symbol, what happened? You should know how many unpaired, not only valency electron, you may also know what happened, how many unpaired electrons are. Okay. For magnesium, they represented like this, but generally what happened, magnesium we present in this manner only, right? Sodium, 1 electron. Beryllium also we can represent. Okay. When you have 2 electrons, they represent like this, but generally what happened when they exist, they may excite actually. Actually, we can represent like this, but when they excite, what happened? Like this. For example, magnesium is there. Configuration is 1s2, 2s2, 2p4, 3s2, 3p0. Now, when they form bonding, what happened? One electron will jump here. So, we are getting electron here and electron here like this. That is the reason you may show like that also, right? So, this is about the symbols. Steps to write the Lewis dot structures. Which steps? Just wait, beta. One minute. Just wait. Again. Now, determine the total number of valence electrons. Steps to write the Lewis dot structure. First of all, you have to see how many valence electrons are available. For anions and negative charge, that means what? For anions, what happened? They are negative charge. That means you have to add one electrons. Okay. And how many octet electrons that molecule should have using the octet rule, and subtract the valence electron from the octet. For the cation, you have to subtract the electrons. For anion, you have to add electrons. We'll show that one by taking an example. Now, if you want to get how many bonds, so divide the number of bonding electrons by 2, you will get the number of bonds. For example, if you have what 2 electrons are there, isn't it? You can divide that one with 2 to get the number of bonds actually. All these things are not required for you, just the rule actually. Once you do that, what happens? It will be easy for you. Tell me better, how many number of Lewis dots present in the chlorine atom?
The 7.
7. 7, sir.
Now I am showing for molecules now, because molecules now important here, how to make the Lewis dot structure for the carbon monoxide. First, you will see the step number 1, the total number of valence electrons in the carbon monoxide. How many there are actually? So you write like this here: carbon 2, 4, correct? Oxygen 2, 6 actually. So we have to take 4 as a valence electron, 6 as a valence electron, right? Now total number of electrons are how many here? 10. Okay. Next, skeleton structure of CO. How to write this one?
7.
The single bond between C and O actually. Put one single bond like this here. Like this you have to put. Then 8 electrons has 3 lone pairs on oxygen to complete the octet configuration. 1 lone pair on the carbon to have like this. For example, you observe again, I am writing again here. Carbon valence electrons how many beta? 4, no? Now 1, 2, 3, and 4. Correct? Oxygen 1, 2, 3, 4, 5, 6. Okay, 4 valence electrons, 6 valence electrons. Now, in this case, what happened? To get octet configuration, oxygen need one lone pair. It need only one lone pair. Where carbon need how many lone pairs actually? 2 lone pairs it need actually. Now, what happening here? Carbon and oxygen. See, carbon and oxygen. They are forming a bond like this. See this bond. This bond here. Correct. Now, what we are getting here? Oxygen 1. I'm writing the carbon electrons as a cross mark like this to easily identify. I'm writing cross mark like this. 4 electrons. Now you are getting oxygen how many? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 electrons are getting. Now, what I'm doing here? So carbon not getting complete octet configuration. And that is the reason what happened. Oxygen also not getting. So what we'll do here, in this case, we'll write like this. That means I'm showing here, instead of writing this one, I'm showing like this. Carbon, 1, 2, 3, 4. Okay. Oxygen, 1, 2, 3, 4, 5, 6, 7. Already completed now. Yeah. Right? Now, how am I writing here? Now, if I combine like this, how many electrons are getting on oxygen? Anybody?
Sir, 8.
8 you are getting? 1, 2, 3, 4, 5, 6, 7, 8. How many electrons oxygen is getting?
Sir, 6.
Carbon getting how many
6.
electrons getting?
6, sir.
6 electrons. Now, is it correct structure?
No, sir.
Oxygen is okay. For oxygen is okay. 8 electrons are getting. Here 1, 2, 3, 4, 5, 6, 7, 8. But carbon 1, 2, 3, 4, 5, 6 only are getting it. So you can't make this structure. So how to make the structure? Now let me see this. To get the octet configuration, they arrange like this. Carbon, oxygen, 1, 2, 3, 4, right? It's 1, 2, 3, 4, next 5, 6. If I write like this. Now this electron also belongs to which one, beta? This electron also belongs to which one?
Oxygen.
Oxygen. Now that means what happened? Here carbon and oxygen forming the covalent bond. Here carbon and oxygen forming also one more covalent bond. But the third bond, if you observe, that bond is also covalent bond, but that electrons are contributed by what? Whom? Oxygen. The both electrons are contributed by whom here? Oxygen. So that is the reason we can represent carbon monoxide like this. Here having remaining 2. Now in this case, if you observe, oxygen is having how many electron, beta? 8. Carbon also having here. Carbon also having octet configuration. Oxygen also having what? Octet configuration. Both are getting octet configurations. So in that case, what happened? To get the gain the octet configuration, what happened? One of the element may give 2 electrons. They can share equally also. This is called what? Day 2 bond action. Isn't it? You see, carbon is getting 8 electrons. Even oxygen also getting 8 electrons. Okay. In this way, we can show. Here we can show what? Now we see you try this CO3 minus 2 today. After completion of the class, you try the CO3 minus 2. Okay. And next thing we will discuss in the next tomorrow class. So this is only today. The remaining things we'll discuss tomorrow. Remaining whatever the structures you're having, we'll discuss. Now you have any doubts with you? Any doubts you're having?
No doubt, sir.
Okay.
Sir, how xenon make a bond, sir?
Xenon actually with only very high electronegative elements like fluorine and oxygen, because of high electronegativity, xenon will form. That means because of high electronegativity of fluorine, they excite even what octet configuration also. Okay, because of high electronegativity, because of high energy on fluorine, what happened? Because the fluorine need one that electron, so that is there is even it can gain electron from what xenon also. So that is because of electronegativity of oxygen and fluorine. Only few students, still 13 students, 13 or 15 members were absent today. Again, I will check the attendance now. How many are there? There now. All of you, please stay with me for 2 minutes. Aditya left out. Where is Aditya? Left out. Aditya Damnekar. Half. Apurva. Apurva. When you joined, Apurva, when you have joined, Atul, Aish, Mohammad Ashif is absent, no? MD Ashif, absent. Omkar PC, absent. Ramya, absent. Sneha BS, absent. Sumit AM, absent. Suraj C, absent. Suraj C and Suraj TU, both are absent. Both Suraj are absent. Vishal, absent. Vishal, when you present, Vishal, when you joined,
Sir, at 9:15.
why late? When I take attendance, you have to attend. Pallavi, absent. Okay. If you have any doubts, you can stay with me. Otherwise, you can log out.
Thank
Thank
you,
you,
sir.
sir.
Thank you.
Thank you,
Thank you,
sir.
sir.
Excuse me, sir.
Bolo